Okay. Well, good morning, everybody. Thank you, Marta, for the kind introduction, and thank you very much to the organizing committee of this workshop for inviting Patricia and myself. It's an honor to speak here today a little bit about real-time monitoring and modeling of workload, opportunities and risks from an occupational safety and health perspective. Patricia and myself, we are with the Federal Institute for Occupational Safety and Health. Patricia is a psychologist, I'm an industrial engineer. What we do in our institute is human factors engineering to have a good design of innovative technologies. And when we spoke with Marta about a possible contribution to the workshop, we said, well, it would be what we can provide is an overview of different technologies in the field of real-time monitoring and modeling. And when we submitted our title, we said of workload, but then we discovered probably to say human states is a little better. And I'll explain in a while why we decided to switch the title a little to real-time monitoring and modeling of human states. As I said, we are with the Federal Institute for Occupational Safety and Health in Germany, and we are a federal research institute of the German government, and our primary mission is to promote safety and health in the workplace. We do that by doing research. We provide policy advice to our German Federal Ministry of Labor and Social Affairs, and we have some statutory and official functions which are related to chemical safety and product safety, but our main focus is doing research for a human-centered design in the world of work and to support the government in regulation, in standardization, but also to support companies and employees. A little more specific, when we take a look at our group, we are from the Human Factors Ergonomics group, and because of that, people are the focus of our work. We take a look at innovative technologies and how to integrate them into modern work systems and to identify risks and opportunities if you have these new technologies in the workplace. We always try to tailor it towards the people's needs and abilities to put the human into the center of everything we do. We have a focus in physically supporting technologies to avoid overload, but also cognitive supporting technologies to optimize cognitive strain regarding to software and hardware. And also we have one section where we do anthropometry, so body scanning. All in all, what we want to do is, as I said before, to tailor the work properly to the human. But to do so, we of course need a lot of knowledge on body measurements, on what do people like, what do people trust, what do people accept. So that's the research we do, finally, to do everything safe, healthy, and competitive. And when we come to today's workshop and the focus, as a human factors engineer, and if you have this kind of innovative technology, you take a look at the task where the technology will support you to. As Marta also has presented, we have different tasks of robots which support in the healthcare sector. So, for example, we have robot assisting therapy, for example, to mobilize patients. We have, on the other hand, we have some kind of teleoperation and surgical operations, like, for example, here with the Da Vinci robot, which supports surgeons during surgery. We have, but also what we do have there is logistics and transportation tasks in a hospital, which is maybe not the core focus of assistive technologies, but still that's what you find in hospitals nowadays. And I think in the healthcare sector, we have some specific requirements, because you might say, well, this is what we know. We do transportation logistics in manufacturing for quite some time. But what is new in a hospital is that you have different people there, because you have the patients there, you have the nurses, you have the doctors, but also you have visitors. And this is something new, because then you have suddenly robots meeting people who don't know the robots. Because in a factory, you always, if you have a visitor, you have an instructed person walking with you, and he explains you how to behave towards the robot. In a hospital, if you meet these kind of systems and you're not, you don't have any kind of experience, maybe you're 70 and visiting your partner, that might be an interesting interaction, and you have to have some knowledge to do a good and proper design there. And also next to the physical part, we also have the cognitive part. So where we engage with patients through conversation, companionship, cognitive stimulation. So all in all, we see, well, it's a quite broad scope of these robots that are developed. And if we then take a look at the resulting tasks and roles of the robots, we see this. We see on one side, we have an interaction of the robot with the patient. On the other side, we might have a robot interacting with a worker. And then we have something in between also, which is the robot interacting with a patient and a worker. And in these different roles, we have different, for example, different automation styles, which are important from a human factors perspective. Because sometimes, sometimes you have, I have the right here. Sometimes you have the automation of a task. Because, for example, if the robot now takes care of a specific task, I think, all right, yes. Yeah. Robot takes care of a specific task, and the worker doesn't have to do that anymore. We are talking about substitution. You take away this task from the worker. If you are here and the robot is giving therapy and you are working with the robot and the patient, he's doing assistance to me. We have, as I said in the introduction, we have different types of tasks. We have physical tasks that are supported by the robot, which are related to the patient, so related to a person. There might be physical tasks where we have the robot, the patient, and the worker. And we have some tasks where, for example, I tell the robot, please bring to Mr. Peters, please bring him something to eat, a tray, or please bring him something to drink. Then he's just doing some kind of object-related task. He's substituting the task. I don't have to do it anymore. And because of all these different tasks and roles, we also have different forms of interaction. We have coexisting systems in healthcare. We have cooperation in sequence. As I said before, for example, if I tell the robot, please bring this tray to Mr. Peters, we have cooperation. He does something, then he comes back and I can send him and he does another task for me. Or we have the real pure collaboration, same place, same task on a patient, for example, in doing any kind of treatment. And for all these different roles and tasks, we have different technologies out there that can, measure the human or detect the human state in some way. We can take a look, as you can see here, we can take a look at the brain. So we have EEG, we can take a look at the muscles, EMG, heart rate, we have extradermal activity. We can take a look at body temperature, eye tracking, we can do pupillometry. We can do some kind of facial tracking. We can do voice and speech. We can do motion capture. So these are all biosignals, or these are all signals, objective data we can record and take any information out of that. And that's why maybe this slide is why we discovered it's a better way to switch the title of our presentation, because first we had workload. The problem is this list, it's not comprehensive, first of all, but still this list is not only for workload, because some are for detecting emotions, which is not really cognitive workload or physical workload. Or maybe it's about attention. Is the robot looking is the patient looking into my direction? So that's why we changed it to human states. So we have all these objective data to get some information about the human. And also what we have subjective data, which is basically just asking the human, which can be done by the robot, and of course, which can also be done by the person giving therapy. But that is, these are the options that we do have. And if we take a look at the advantages of these, is if we are going for biosignals and taking a look at the humans, we have real-time monitoring, we have immediate insights into human states, and I would say in theory, we can have immediate reaction of the robotic system to the person. This is a big opportunity. But as you can see, to reach that goal, we have quite some challenges. Because most signals are influenced by several factors such as age, fitness, movement, environmental conditions. So it's not that easy just collecting the information and then interpreting the information and getting something that you need for the robotic control out of that isn't as easy. It's not that you take a look, oh, it's one degree increase in body temperature. That means that the human body and the human behavior is complex. That's what it says here. So it's really sometimes difficult to correlate specific signals to the outcome you expect. And also, I would say, even in the age of AI, just collecting data doesn't help. So not by increasing the amount of data, you don't get better results. That's at least the experience that we have in our experiments. You might have high costs because, of course, you need most of the time advanced equipment to collect these biosignals. You have discomfort and disruption because you have to attach these sensors. Not all of them. If you look at somebody with a camera, of course, you don't have that. And the biggest issue is you have data privacy issues and the perceived feeling of surveillance. Because, of course, you want to assist the human, but to detect the human state, you need to surveil him 24/7, or at least during the whole interaction. You save the data, and maybe you can do something different with the data. For example, from a worker's perspective, you can detect how long did he work? Was that efficient? Was he focused? And maybe, well, sometimes that has a big issue, has a big influence on your work system. Just briefly, with the questionnaires, what I said, if you have, if you ask people, it's ease of use. You just ask, you get an answer. You have scales which are validated, and you simply get feedback from the people, which is good. You can have more details. You can ask another question. You go more into detail. Also, if you have the questions maybe asked by a robot, because nowadays developments with large language models gives you more possibilities than we had 2 or 3 years ago. Well, challenges, it's no real-time data, right? Also, the answers might be biased because some people answer what they maybe think you want to hear. And you have an interruption of process and task. So what would be the key takeaways or questions for robotic engineers based on that, what I've just presented? Is, well, first of all, if you design these kinds of systems, you need to consider which task needs to be assisted and automated, and why. So what is the benefit for whom? You really have to note down the use case. Is it for the patient? Is it for the worker? Is it for the company? Sometimes if it's just to have the technology, I can tell you from research projects, that's really tough if you put that into practice to get the acceptance of the people. Just because of technology is always a bad answer. Consider what data you really need. Take a look in what control of the robotic system do I need? Do I interact with the worker? Do I interact with the patient? Do I have cognitive support? Do I have physical support? And just collect the data you need. Don't just collect all the data you can get, because the problem is you move out of practice, out of the lab, have a high want to receive a high TRL level. You go to the company, the data privacy officer tells you what data do you really need, and don't use the others. So, and it's always good to consider that in advance. Take into account how this data collection will look like in practice, because in the lab, it doesn't matter if you prepare the patient for 2 hours. If you're in the hospital and if you have like 15 minutes time for the treatment, still consider that when you develop this kind of technology, and keep in mind what effects this data collection will have on the people affected, and check if it's worth it. So if you are focusing on a big problem and relieving, and you're putting relief on the workers, you can also collect sensitive data. But if you're having just like a small, well, now the work is a little nicer, but for that, I collect your heart rate variability. I take an EEG, and every day you have to put an EMG to your body and glue it. Then probably I would say it's not worth it. And this is all very important when you put it into practice to get the trust and acceptance of the people. And to come to the second part of our presentation, let's now imagine you have done all that and you have developed a beneficial technical solution, and you want to put it into practice. Because what we have done for the European Agency for Occupational Safety and Health, an online risk assessment tool, and Patricia is going to present or give you a glimpse on this kind of risk assessment, what you do when you put these systems, or should do when you put these systems into practice.
Yes, thank you, Sascha, and also thank you, Marta and Vanzu, for inviting us. Good morning, everyone. Yeah, as Sascha has said, let's now imagine we have developed a system that's ready to go into a hospital setting, into a healthcare setting that's ready for the market. What should a company or what should a hospital, this kind of organization, do? And within Europe, we have the OSH Framework Directive, which is a directive that is applied in all European countries. And they have a key element in that directive, and this is the element of risk assessment. So every company, every organization has to perform a risk assessment for any new and emerging technologies, such as AI-based systems or robotics that are introduced to the workplace, but also for any other work equipment. So that's not only a specialty for robotics, but for any kind of work equipment. And because of that, the EU OSHA, they have a large pool of tools serving companies or organizations how to perform these kind of risk assessments. And one of these risk assessment online tools we have developed as a Federal Institute for EU OSHA based on a different project we also did for EU OSHA, where we collected all the relevant information that then went into the tool. And within the next couple of minutes, I would just briefly like to present to you the tool. It's all online, freely available. And if you're interested in that, you can check out our website, our institute websites, or the EU OSHA website, where you find the specific tool. And first of all, the idea of this tool is we have different types of modules. We have one mandatory module that always applies to if you want to use any kind of AI-based system or advanced robotics for any kind of automation within your hospital, in this case, for example. And then you have one optional tool, and here you have to question yourself, the task I'm looking at, is the system supporting a cognitive task or is it supporting a physical task? And then you pick your optional tool. And I've just, it's quite complex. And just to give you an idea what the design looks like, you can see here you have different modules and submodules you can click through. And you will always be asked specific questions about relevant risks. And the risks are clustered in a way that they either refer to psychosocial risks, to organizational risks, or to physical risks. And when we're looking, for example, at organizational risks, which apply to all kinds of AI-based systems and advanced robotics, I won't go through all of them because there are a lot, but just in the organizational category, you see, for example, a very important aspect is whether the robotic system, for example, has been implemented by using some kind of worker involvement, because we know from literature that this is a very important tool. So you have to ensure that you have, for example, spoken to your worker representatives, or maybe you have already collected some feedback from some nurses or doctors who really stated what kind of needs they have. Also, what is also might sound like common sense, but especially in relation to advanced robotics, a clear communication strategy is really important. You have to, as we have just heard, especially when we are talking about systems that collect a lot of data, it's very important that you have very transparent communication strategies about what data is collected and what is done and happening with this kind of data. When we look at the dimension of psychosocial risks, and again here we find a collection of aspects that some of them are new to new risks, but some of these risks also refer to any other kind of technology you use at the workplace. So it's kind of a combination of new and older risks. But again, we want to highlight that they are important, especially in relation to advanced robotics. And so here we're talking about aspects like trust in automation, So have you ensured that your workforce has some kind of adequate level of trust toward the system? Have you considered the workload that results from interacting with the system? So because we always have the risk that people might feel overwhelmed by the interaction. We have sometimes a workforce who might not be too open towards technology. Again, this is very sector specific, especially in healthcare. We might see a workforce who really needs support, but at the same time, they are not that familiar with very advanced technologies. So the intention might have been to optimize the workload, but the result could be that people feel really higher levels of strain and stress from the interaction. So that's something to consider. And also interaction principles, also nothing really new, but especially with robotic systems, Sascha has mentioned it earlier, we have different people interacting with the system. Some might be very familiar, others might not be. So have you really considered all the interaction modalities? Are we talking about some kind of speech interaction, some kind of gesture, or do we need an additional tablet or something to smooth the interaction? Again, something you have to think about when you want these kind of technologies running through your hallways. When we are looking at specific risks associated when we are talking about a physical automation of physical tasks, again, we have some specialities in the psychosocial category. Here we see, of course, the issue of preventing the loss of responsibility, because some people, we know that from literature, really have the feeling that they do not feel responsible for the task anymore. And again, the robotic design features have to meet the application context. So when it's loud and noisy, for example, or there's a lot of coming and going, we have maybe a big hallway, we need some other design features than we might have in a very closed room, for example. Then, of course, one very important aspect when we are talking about the automation of physical tasks is related to physical safety. In here, it is very important that not only the developers, but when we also implement the technology, take a look at the relevant standards and regulations. So this is just something we have included into the risk assessment tool, that people are really aware, look, there is a lot of regulation you have to take into consideration, like the machinery regulation or the standards on safety for robotic devices. So people have to have a look at those documents. And then one very important aspect when it comes to the automation of cognitive tasks, again, when we are looking at the psychosocial dimension, here especially the aspect of data fairness and data process control becomes very important. So here, this might be more a situation where we're thinking about some kind of innovative management of patients, for example, management of scheduling different nursing and doctoral tasks. We have to have the process control still has to be within the hands of a human at last. Because again, especially in the hospital, we are dealing with very sensitive data, definitely. And then last but not least, one specialty when we are, again, this might not be entirely applicable to the hospital context, but it's in the tool and I didn't want to miss it out. When we're talking about the automation of cognitive tasks and a specialty related to physical aspects, here, of course, we have the issue of prolonged sitting, which could be a new and additional risk. Again, this might not be the case so much for healthcare, although if we think of maybe more the staff in the back end, not actually doing any healthcare tasks, but if we think of some kind of controlling unit in a hospital, this would be also applicable. So this was just a quick run through this tool we have developed. And if you're interested in this, I very much invite you to have a look at the website. And also maybe just as a finishing sentence, I think it's, it's not like that you can do it within half an hour and say, okay, risk assessment done, I can put it down to the books. But it's also, the idea is really to have some awareness raising tools. So people, not only developers, but really the people who implement advanced robotics and AI-based systems in a company, in an organization, have the idea of what are the different risks we really have to take into consideration, because sometimes some of them might get forgotten. With that, I would like to thank you for your attention.